Hello, everyone. We're the Sonos SCOPE team. I'm Robert. These are my teammates Kai, John, Kelly, Lilia, and Franton. And this year we worked on a project called Playtest, Characterizing Speaker Walking. I'd also like to take a moment to thank our faculty advisor, Sam Mahalka, and our liaisons at Sonos, Farhad Mirbad, Vicky Chen, Bridget Hunter-Jones, and Tim Sheen. So, for those who don't know, Sonos is a Wi-Fi speaker company that's known for fitting powerful speakers into small form factors. Here are a few of their most popular speakers. And for reference, the largest speaker, shown on the right, is called their Play 5, and that's the speaker that we worked with throughout this project. So as I mentioned, this project focused on characterizing speaker walking. But what is speaker walking? Well, sometimes speakers will vibrate so much that they actually move across the surface that they're sitting on. Could look something like this. Now, obviously, this is bad for consumers. So this is, of course, bad for consumers because you could have a speaker that actually walks off of the surface that it's sitting on, as just shown. So in the process of designing new speakers, it's, of course, very important that Sonos makes sure they eliminate this behavior completely from every single speaker. But this is actually a very difficult problem to solve because there's no analytical model that Sonos can use to simulate this behavior. It's incredibly complex. So in the past, Sonos has used accelerometers to test their designs for speaker designs for speaker walking. And this has allowed them to eliminate the behavior, but it hasn't moved them much closer to understanding why and when this behavior is really occurring. The accelerometers would be placed all over the speaker body, and they would measure the acceleration at each of these points. But they weren't able to investigate what was going on between the feet and the surface they were sitting on, which is really where the interesting interactions of walking are occurring. So to investigate a little bit more of why does speaker walking occur, we, with this project, looked at force sensors to measure the force at each feet of the speaker. And this allowed us to look at the contact between the surface the speaker is sitting on and the foot of the speaker. So with that, we developed a test system prototype that we could put the speaker on as such, so that a force sensor is under each foot. We would then measure the force as we played songs that would induce walking on the speaker. And this allowed us to gain insights into what is actually going on in the system and why walking is occurring. And just some early assumptions that we had going into this project that turned out to not be so correct. We assumed that the feet lift off during walking, that walking behavior looked a little something like this, where it would rock back and forth, and the feet would actually leave the surface it was sitting on as it walked. And as such, we didn't think that friction played a very large role in the behavior because it was more of a rocking back and forth. We'd also thought that because the feet left the surface, we'd be able to measure zero force with the force sensors, because at those moments where the speaker left the surface it was sitting on, the feet would actually exert no force on the force sensors.
So I'm going to talk just a little bit about our process before we dig into the results. We started this project at the beginning of the year with a Play 5 speaker that we got from Sonos, and since they obviously don't release any speakers that actually do walk, we had to mess with it a little bit to sort of tease out that walking behavior. We replaced the feet of the speaker and we tried it on some different surfaces. And then we entered this iterative design loop where we would design and fabricate a testing platform. We would design and conduct some experiments that we sought to answer some questions and then analyze the data. And with that data and with the input of our advisors and our liaisons, we would continue to iterate on both our platform design and our experimental design. And we went through this loop several times. We went through 3 complete iterations over our platform design with many other smaller changes. We did dozens of experimental protocol and over 15 gigabytes of experimental data. So that brought us to this photo, which is what the latest iteration of our testing platform looked like. And a couple of key features to note: we have it mounted on a very, very sturdy table with some very thick aluminum in order to try to isolate our system from any external vibrations. And we actually found you can see those little slips of paper under each foot. We found that in order to induce walking in our speaker, we had to actually lower friction under the speaker, which we did by using a little bit of paper. So we ran a lot of experiments, and we came up with a few valuable insights that we presented to Sonos, some about the actual platform design and some about speaker walking as a behavior itself. So with regards to the platform design, we discovered that the force sensors that we use must be spec'd extremely carefully in order to measure high frequency vibrations. And that's because if the speaker is vibrating and the sensors or the platform happen to vibrate with it, that will introduce basically unknown data that we can't really separate from our actual speaker data. And these sensors, in order to be stiff enough to be resilient to that vibration and still measure very slight changes in the force, and additionally, in order to measure forces in directions other than just up and down, they're very expensive. So a little bit about our insights into speaker walking itself. To come back to the assumptions that Robbie was mentioning earlier, we actually found these not to be true. We never saw any sort of zero force readings in our sensor data, and we actually verified this by looking at some high-speed camera footage, which you can see here. It's very hard to see, but basically, if you look very closely, you can see that the speaker feet are sliding back and forth very slightly over time, and that adds up to make the speaker walk across the platform. And as a result, we realized that friction actually does play a very large role in this system, which is not great because Sonos can't completely control what sort of surfaces their consumers put their speakers on. And if they put it on something non-ideal, then the speaker, well, it might walk. Anyway, we also found a few promising patterns in our data which we could use to differentiate non-walking from walking behaviors and designs. This is illustrated by this graph, which you can see the force measured under the feet over time. And in blue, a non-walking pattern would consistently read higher forces than the walking designs. So moving forward, we have used these insights to inform Sonos, and they can hopefully use this knowledge to help in their design of any future speaker models. Additionally, that trends that I just mentioned, with further experimentation and additional refinement, may be able to be used in this sort of test rig to diagnose speaker walking during their design process in-house. Thank you very much for listening. We'd like to thank our faculty advisors again and our friends at Sonos for all of their support through the project.